Spaceman Spoof is having a bad hair day, so he fires his thrusters for 12 seconds with a thrust of 2,750 newtons. Calculate the impulse this applies to his ship. If you know some of the references I have in this example, try not to laugh, right? But anyway, I think partly my motivation was when I wrote this drawing, I was trying to do nice hair and it just turned out really messy. And so I thought, well, maybe the backstory is he's having a bad hair day. And so he's maybe firing his thrusters to get to the hair salon or something. Who knows? Anyways, since impulse is equal to force times time, that's just what I'm writing here. Now, we had, I think on the key concepts page, we said this was force average. We said impulse was a vector. Force, of course, is a vector. But I think we can leave that notation off here. I mean, if you want to, you can leave it and kind of say like, okay, we're working the x component. But this is all pretty one-dimensional. He's just speeding up to the right. So I think the force points to the right. That's on Spaceman Spoof's little spacecraft here. Maybe it's an imaginary spacecraft. I don't know. And therefore, impulse would also point to the right. So I guess if I really want to give a complete answer, I'm going to calculate what it is and then say that it points to the right. But in terms of calculating it, it really is quite straightforward given the information I have there, because I'm given this force of 2,750. Hang on. That's the pen kind of stuck to the page there. I want to make sure that 7 doesn't look like a 2. 2,750 newtons multiplied by, I'm just going to identify the delta T with the 12 seconds that I'm given. Okay. And then put that in my calculator, 2,750 times 12, in case you don't know how to do that in your head. I don't know how to do that in my head. Some people are really good at that, though, right? I'm not one of those people. So I get my calculator. And then we could ask, like, well, let's see, what do I want to do with the units? I think it's fine to make it a Newton second, if you like, or maybe if I wanted to. I mean, this is a good question, like what kind of unit should it have, right? Recall that the Newton is a kilogram meter per second squared, and then times a second, I think would make this a kilogram meter per second, which that actually might make sense to have the answer be in kilogram meter per second, because momentum is equal to mv, and mass times velocity would be kilogram meter per second. So that, again, it's maybe reasonable that this could be equivalent to a Newton times a second. So that's kind of cool that we got to explore that here. A question that has sometimes come up is, so like if we do energy and work, right, we get to use joules, right? If you do a Newton times a meter, we've defined that to be a joule as a unit that we can use for describing energy. Is there a unit like that that would simplify this for momentum? And my answer is no. And well, the answer is no, not just my answer. I'd say my answer and the answer is no. My wish is that there was one. I think if I had to give it a name, I'd say let's call it the Descartes, because as far as I know, there is no unit called the Descartes yet, and momentum was first kind of invented by René Descartes. But for whatever reason, that has not happened as far as I know. So we're stuck with units like kilogram meter per second, which is probably the more straightforward one to use here in light of what we're doing with momentum.